Hello! So this is gonna be the ANCOVA assignment that I'm doing. The last 15 minutes cut off on me, so I'm just gonna start from where I did. Here we go. So here these commands essentially set up my workspace. They let me set up my working directory. They allow me to attach the data, and it also allows me to load the packages for me to use the functions, because that's kind of important. This command allows me to set stress as a categorical factor. So here you see that I'm labeling 1, 2, and 3 as not stressful, moderately stressful, and extremely stressful. So we're going to run that. Oh, I just said I wasn't going to run it. Oh, well, dark on it. Now I have to run this stuff. Yep. I already ran this command, so now, just as a precaution to make sure that R did what I told it to do, you're going to run these, and it did not. So we're going to run it again, and now we're going to check it. There we go. So now we're going to explore our data. We're going to get our descriptive statistics. And here we're going to get our mean, our median, our standard deviation, standard error, and also our skewness and kurtosis. But the main thing I kind of want to look at here that I want to pay more attention to are the means, because that's essentially what's being tested here in ANCOVA. So looking at the means for our not stressful group, it's 30.2. Looking at it for moderately stressful, it's 33.8 or 33.9 if you want to round. And then for extremely stressful, you get 29.9 if you want to round, but 29.8. So just kind of eyeballing it, you see that they're not really different from one another. So that's a little bit concerning, but we're going to still run through the analysis to make sure and let the analysis and let R tell us, or let R confirm this is what it is. So now we're going to test for assumption of homogeneity of variance. We want this to be non-significant. You want it to be non-significant because if it was significant, then that would mean your variances between your groups are different, and that's not what you want, because then you'd violate the assumption. Silly. So here is our command for our ANCOVA model. So I'm going to run this, and this ANCOVA is testing the main effects of stress on total well-being, or just well-being overall. Here we go. So here you're not seeing a significant value, but the F statistic is rather worth looking at. The F statistic is the comparison of how good the model is compared to how bad it is. So when you're calculating the F statistic, your mean sum of squares of the model is divided by the mean sum of squares of the residuals. So if your value was to be more than 1, or more than, if your values of the denominator, let's say that, because that's a mouthful to say. If your denominator is bigger than your denominator, then you're going to have a bigger ratio. That means you have more systematic variance, things that you can explain, than your unexplained ones. Well, than your unexplained variance. So basically, if you have the bigger the F value, the better. Here, yeah. That's all I got to say is Mia. Um, so I mean that's still something to take into account, but let's see what happens when we actually conduct our ANCOVA. The next assumption that we want to check is for the independence between covariate and predictor variable. You want this, you want to check for this to make sure that your predictor variable, in this case stress, is not related to depression in any sort of way. So this is essentially the command. We ran this, and remember to test for independence between your covariate and your predictor variable. You would want to use you would want to conduct an ANOVA or a t-test. In this case, I went with how Andy Field did it in his book, an ANOVA. So here we're not seeing any of the main effects of stress on depression. So this is a good thing. This is kind of interesting here, because it's kind of it appears that it could possibly explain for depression, but it's not significant, so we're not gonna worry about it. So we're just gonna move on, and take our assumption for what it is. So now we're gonna do our ANCOVA model. So this command allows me to create a linear model for ANCOVA, for the ANCOVA model, and then we're gonna do a summary. Oh no! Well, this sucks. Kind of. So essentially what you're seeing here, you're seeing obviously a non-significant value, but that's okay. It is what it is at this point. F statistic is kind of low, and comparing it to what we saw before with the ANOVA model between that incorporates stress and total well-being, you see that it went down. So that means that when you include depression into the equation or into the analysis, it means that there's like not a lot of there's more unexplained variance. So there's a lot more things that we have to take into consideration when accounting for stress and when accounting for depression for this procedure. Okay, so one thing I kind of want to talk about is order. So in this case, order does matter. Depending on the type depending on the type that you want, you can calculate the sum of squares, a certain sum of squares for your ANCOVA. So if we were to take into account order, this is the type of commands that we would use. This would be covariate first. This is stress group first. So yeah, that's what we would take into account when we're thinking about order. So adjusted means, so I'm going to run these. So adjusted means this is essentially the means that we're looking at, but they're adjusted from what we've saw before. Reason being is because you can't really interpret your means before you do this. So now that we're looking at them adjusted, we can kind of get a better eyeball of it, even though our ANCOVA model just confirmed it, but I still want to look at it anyway. So this is the original, and this is adjusted for the lower 95th percent confidence interval. So here you definitely see when you're taking into this account, they're not ultimately different. Same thing here. Now standard error, they're not far from each other either. So basically, we weren't different. Well, these groups weren't different from one another. Now I'm gonna do a scatter plot really quickly. So we're gonna do a scatter plot kind of just to see the relationship between depression and total well-being. What you see here, basically, it's in a way to say this, as depression goes up, total well-being goes down, and which is something that you obviously you would see when you're taking into account depression. You're not gonna be like completely up there, so your well-being is gonna suffer. Yep. Alrighty. Now moving along. Now we're gonna test for homoscedasticity, and linearity. I don't know why I put normality. It's linearity. So we're gonna plot that. Alright. So these essentially show us our heteroscedasticity, our possible homoscedasticity. These are kind of like all over the place, and that's not what we want. Well, actually, low key, it shows that we're linear, but as far as funnel shape, yeah, no, this just doesn't do it. No, no. I'm trying to make excuses for my fake data. So with linearity, we could see that this is obviously not linear. Most of our scores are actually off the line. So as far as linearity is concerned, no, we're not linear at all. So now homogeneity of regression slopes. Gonna run this. And this is essentially testing to make sure, or just to check that the relationship between your covariate and your outcome variable are the same within other groups. So here we actually see it. We're not really focusing on this, but we're gonna focus more so on this right here, because this is saying that there is an interaction here, and within that particular interaction with that group, with one of those groups, there's a significant difference in one of them. And this is not good, because we're violating the assumptions. So now for post hoc, whichever's, we're gonna conduct that's what I just said. This command runs the post hoc test. The specific test that we're going to run is Tukey, since our group variances are the same, and so is our data is normally distributed. And then plus we're also running this because I did not have a specific hypothesis that I wanted to run. So I'm data mining, which is also not a good thing, but hey, this is statistics. So here we're not seeing any anything at all. So with a post hoc, it's showing that there's no significant differences or significant comparisons between any of these groups. So overall, there's nothing here. So there is no main effect of stress on well-being while controlling for depression. And this is what we would use if we were to do a planned contrast. Yep, and that's it.